last lesson in this unit is about the properties of logarithms, okay? Logs are kind of annoying to have to deal with, but they actually serve a pretty good purpose for a lot of different things. It is very helpful and useful to know how to manipulate logs to make them more simplified and to help you solve for them and things like that. One thing that I like to mention here is that if you, again, think about what a log is. So log, let's say log b of x equals y. Again, when you rewrite that, that's b to the y power equals x. Okay? When you're talking about this thing, right, when you're talking about logs, you're really kind of talking about exponents. So they're very similar to your rules of exponents in that when I have the log of two numbers that are multiplied, I can separate it into log of those two things, two separate logs that are added, okay? And if I have the log of two things that are divided, I can separate it into two logs that are subtracted. And the last one, again, if you have the log and you have a power in there, you can actually bring that power in front as multiplication. So you see how that's very similar to what we do with exponents. When you multiply, you add the exponents. When you divide, you can subtract the exponents. When you have a power to a power, you multiply the exponents. So again, I mean, that's just kind of a very vague, generic thing on how those work. But these are our three main properties of logarithms that we're going to talk about right now. One of the reasons these are so useful is because once upon a time, I know this is going to be hard for y'all to believe, you technologically advanced children, is that we didn't have calculators that had these lovely log buttons, okay? We were lucky to have one that just did the four functions, add, subtract, multiply, and divide. We were, you know, really living big with those things. And so logs, you really can't find the log of certain things without using a calculator. For example, right here on this one they had log 3 of 28. Well, if I do 3 to the what power equals 28, I'm not going to come up with anything. I can't turn a 28 into a 3 using any kind of exponent besides some ridiculous, ugly fraction thing. And so the best way to do that was with the calculator type thing, but not everyone had a calculator. So we have these things called log tables, okay? They would have the log of certain things, only specific numbers, written out, and you have to use your properties of logs to simplify and to figure out a way to manipulate this equation using the numbers you know, okay? So that's kind of what they've done here. They've told you what log 3 of 28 is, and they've told you what log 3 of 4 is, okay? So one thing they wanted you to figure out is what is log 3 of 7, okay? Well, what they did is they said, well, 7 is actually 28 divided by 4. And if that's true, I can just take the log 3 of 28 and subtract the log 3 of 4, and that will tell me approximately what the log 3 of 7 is. Okay, same thing here with 36. It got a little more complicated because 36, they said, well, that's 3 squared times 4. And you may say, well, why did they use 3? Because they didn't give us 3. Well, here's a little handy rule, is another one that they should have put up here. If you have the log and the base and the number in here are the same, that is always going to equal 1. Okay? And if you have, this one kind of builds on this one, if you have that log and the bases are the same, but you have an exponent up here, it's always going to just equal whatever that exponent is. Again, because of this rule, you can bring that number down in front and multiply, but the log b of b is just 1, and 1 times 3 is just going to be 3. So that's the rule they used here. They said, well, 3 squared, log 3 of 3 squared is just 2, because again, that's log 3 of 3 is 1, bring down the 2, that's multiplying, and then you could simplify it from there. Okay? Same thing here. They said 256 is actually 4 to the 4th power. So I can do 4 times what log 3 of 4 is and get a good estimate. Okay? So that's kind of what we're going to do down here in these exercises. And I don't know how far I'm going to go into this, but we're going to talk about it anyway. So the very first one, they've given you 3, and they've given you 7. Okay? And they want you to figure out 21. Well, you know that 21 is the same thing as 3 times 7. I think everyone will agree with that. So if I'm going to evaluate my two logs, I can add the log 12 of 3 to the log 12 of 7, and that will give me my solution. So in this case, that's 0.4421 plus 0.7831. When you add those up, that's going to be a 2 and a 5 and a 1 with a 2 and a 11, 12, 1.2252. I was just a hero and did that without a calculator because I know on your test you're not going to get to use one. Okay? Maybe not a bad idea to check me though as I go because, you know, I get a little out of control. So same thing when you're doing this next one, 7 over 3. Okay, that's the two things we have. So again, I can just take the log 12 of 7 minus the log 12 of 3. Okay, so again, that's 0.7831 minus 0.4421. When you subtract, that's a 0, that's a 1, that's a 4, that is a 3. So there's your solution. I should have stacked the last one. That probably would have made me feel more confident about it. Same thing here, log 12 of, I have a 49. Well, I know that 49 is 7 squared, okay? So my properties of log say that I can bring that 2 down and just say that's 2 times the log 12 of 7. Well, the log 12 of 7 is 0.7831. When I multiply that by 2, I'm going to cheat this time and use my calculator. Don't judge me. You probably want to too. I will tell you that another thing you could do here, it might be annoying, but it might be easier for you, again, like maybe on your test when you don't have a calculator, is knowing that, well, 2 of that is just 0.7831 plus 0.7831. You know, that's the same thing. I could have said instead of 7 squared that this is 7 times 7 and then just added those two together. Either one would work just fine. For the rest of these, I'm not going to go ahead and simplify it. We'll just talk about how you would do it. Okay, so 36 is 3 times 12. Actually, maybe I will go ahead and do this one. I have 3 times 12, okay? So that is just the log 12 of 3 plus the log 12 of 12. Well, this log 12 of 12, again, because these two numbers are the same, that equals 1, plus the log 12 of 3 is 0.4421, so that equals 1.4421. Okay, 63, oh, 63, what is 63? 63 is 7 times 9. 7, and instead of saying 9, I'm going to say 3 squared. So if I was going to do this, I would do the log 12 of 7 plus 2 times the log 12 of 3. Okay. 27 is 3 cubed. 49 is 7 squared. So I could do the same thing here. 3 cubed, 7 squared. So that's going to be 3 times the log 12 of 3 minus 2 times the log 12 of 7. You kind of get how some of those work. Same thing here. Again, I'm not going to solve any of these, I don't think. I'm just going to help you set them up. This time they gave you 3 and they gave you 4. Okay, and it's a log of 5. So 12, again, that's just 3 times 4. So I would just add log 5 of 3 plus the log 5 of 4. Okay, 100, oh, how do you get a 100? Well, that is 20 times 4. No, it's not. It's 20 times 5. Yeah? Or a better one, that's probably a dumb one, would be 25 times 4. How does that help me out? Well, again, 25 is just 5 squared times 4. So for this one, I could do the log 5 of 5 squared plus the log 5 of 4. Well, the log 5 of 5 squared is just going to be 2 plus the log 5 of 4. Again, I'm not going to finish that one. What about 0.75? It might be helpful to turn that into a fraction, right? That's 3/4. So again, that's going to be the log 5 of 3 minus the log 5 of 4. Again, I'm not simplifying this and actually doing the math here. You should be, and you will be on your homework. 144 is actually 12 squared, and you kind of know that. But how does a 12 squared help you? Well, 144 is actually also 16 times 9, okay? And there's a couple ways. I'm going to do this both ways, 12 squared and 16 times 9, okay? So I could either say, well, 16 is 4 squared, and that's 3 squared, okay? Or I could say that 12 is 3 times 4 squared. Either one would get me the same answer. Okay, so I could either do the log 5 of 3 plus the log 5 of 2, and 4, sorry, 4, and multiply all of that by 2, okay? Or I could put 2's in front of both of them. Either one would get you the same answer, and if you really think about it for a second, it's kind of obvious. Again, this is 3 cubed, and that's 4 squared, so that would be 3 times the log 5 of 3 minus 2 times the log 5 of 4. I could simplify it from there. 375 gross. 375 is actually 125 times 3. Yeah, I cheated a little and used my calculator. Again, don't judge me. 125 is 5 cubed. So that's going to be 3 times the log 5 of 5, which is just 3, plus log 5 of 3. Okay? So that's how we kind of use these properties of logs with simplifying numbers. Again, I understand that now you have a calculator and that's what you would like to do, but I haven't taught you how to use the calculator yet, and you're not going to get to use it on this test. Okay, so know your properties of logs. Where they actually come in really useful is when you're solving. So just to give you a little break, I'm going to go ahead and pause this video, and then I'll do the back on a separate one.